Hello everyone, I welcome you all to this lecture. In this lecture, I am going to construct few of the automatas for some regular languages. So in the previous class, we have discussed the deterministic and non-deterministic behavior of an automata, right? Every automata we write for a regular language, okay? So when we are going to construct an automata, I'll give you, let's say in a question, a regular language is given and we need to draw the automata. So first try to understand few of the properties of regular languages and then we construct. So how do we define the regular language? The very first property of the regular language or any language, a finite language or all the finite languages are regular. So any language which is having finite number of strings in the set of a string, or you can say the vocabulary of the language, that language we consider as a regular language. Another thing, if a language is defined over unary alphabet means that alphabet is having only one symbol. So a language is defined by just taking one symbol. The language may have infinite number of strings or finite number. If it is having finite number, then it is definitely regular. If it is having infinite number of strings, then we need to check how those strings are being generated. If those strings are following arithmetic progression AP in terms of their length, if they are following the arithmetic progression, then the language is regular. Otherwise, the language will be considered as non-regular. I'll take example, right? So the third point is, if a regular consists of infinite number of inputs, so rather than single input symbol, there may be 2, 3, 4, any number of input symbols are there. So if a language is defined by taking a larger alphabet set where n number of input symbols are there, then there has to be one important thing which we need to ensure, that then the symbols does not have or should not have any relationship in between. It should not be like that A should come n number of times, B should come n number of times, or C should come n number of times, or maybe A is coming n times, B should come 2n times. So there should not be relationships between the different symbols. Okay, so if it is like that, then also we can claim a language as regular. So please do remember, when we discuss the operations on languages, then we discuss few more properties, but as of now, just to define the regular language, please do remember all these things and take few examples. So the very first example I am taking L1. L1 is defined over an alphabet that is having only one single, so unary alphabet you can say. Now this language is defined like it is having epsilon, 1 length string, 2 length, 3 length. So if I consider this language is generating a kind of AP. It is defined over unary alphabet. So this is 0 length, then 1 length, then 2 length, then 3 length, then 4 length, and so on. So this is an AP. That means this language is regular. If this language is regular, we can draw an automata for this. But there are two types of automaton we have discussed, non-deterministic and deterministic. There are million Moore machine, but because we are here intended to just either accept such kind of strings or reject any illegal string in this particular language. So this is acceptor or rejector kind of thing. So we can draw either NFA or DFA. Okay, the power of NFA and DFA are same, right? So if you want to draw the automata here, automata has 5 tuples. So first we need to decide the initial state. So let's say Q0 is the initial state. Okay, now I'm not bothering whether I'm drawing the NFA or DFA. It is easy to draw NFA as compared to DFA. Okay, later on we will understand how to convert NFA to DFA. So if this is the initial state, because this language is generating empty string epsilon, that means initial without taking any input should lead to the final state. So you just start the machine, it was on initial, and without giving any input it is just reaching to the final state. So that means initial state is final state also. So if any of the automata is accepting null string, that means initial state is final state also. So please do remember, if any string except epsilon, then initial state will be considered as final state. Now if it is accepting 0 or 0 0 or 0, any combination, that means there is a loop of this input 0. So there is only one state in this. So if you write set of, let's say, state q, that is having only q0. If you want to write set of alphabet, that is only one symbol 0. If you want to write initial state, that is q0. If you want to write final state, that is also q0. There is only single, and remaining this delta is drawn as a diagram. So all these 5 tuples will define the automata. Now let's draw the automata for this. This language is having what kind of property, whether it is regular or not. The alphabet is, it is defined over 0 and 1. It is having 0 length string, 1 length, 2 length, all possible combination, then 3 length, then 4 length, and so on. So there are 2 symbols, but these 2 symbols doesn't have any relationship. Every possible combination is coming. So that means this language is regular language, right? So if we want to draw an automata, again we need to draw an initial state. So let's say q0 I am drawing as initial state. You can give any name, a, b, c, d if you want. Initial if it is, and if epsilon is generated or there in the string list, then initial need to be final. So this is final, and this is initial state also. So you put an arrow and double circle here because of this epsilon. Okay, if epsilon I remove from that, then this q0 will not be a final state, or should not be a final state. Then it can accept a 0 or 1. So that means there is a loop. 0 can come n number of times, 1 can come n number of times. So we can put a 0, or means in automata we put comma. So either 0 or 1 symbol can come n number of times in any of the manner. That means this is one possible automata. You can put even 2 if you don't want to put comma. So don't get confused if you are new in this particular subject. 0 comma 1 means either 0 or 1 it is coming. Okay, n number of times. So by following this automata, you can generate any such a string. If you want to generate, let's say if I take any string from this, let's say if I have taken 101 string. Now we start from q0, that was the initial state. When this 1 will come, it will lead us to q0 only, because when 1 comes on q0, it is on q0. When again 0 comes, it is again on q0. When again 1 comes, it is again on q0, and this q0 is the final state. That means this string is legal string according to this automata, right? Then the next, let's say there is another language L3 which is defined the alphabet 0 comma 1, and it is generating this particular language, but it doesn't have. So this language, you need to identify the property of this language. In this language, if you focus on the very first thing, it doesn't accept epsilon. So that means initial state should not be final state. So if I am generating q0 as initial state, it is not the final one, it is only initial one. So I will not double circle it because epsilon is not in the set. Now next property, before creating the automata, we need to understand the property of the language. In this, if you notice that every string is starting with 0, although there are 2 symbols in set of alphabet, but every string is starting with 0. So the very first symbol will come as 0, right? So the very first symbol will come as 0, and here it is. Let's say we are reaching any new name you can give. These names does not affect much of the behavior of the automata. So you can take q0, q1, or x or y, or a or b, whatever. So when 0 is coming here, you are reaching q1, and because 0 can be generated in this language, that means q1 should be the final one also. If q1 will not be the final one, this 0 will not be generated, right? So initial is not final because there is no epsilon in the list of a string, but this q1 is the final because 0, 1 length string, this automata can accept or generate, right? Now 2 length string, 3 length string in the combination of 0 1 0 1. So now because there is no count maintained, we can apply loop here. So either 0 can come n number of times or 1 can come n number of times. Initially there has to be a 0 in the beginning. Okay, so this is the automata we can draw for this. If you want to define all the tuples, then list of states will have q0 and q1. There are 2 states. Input symbol I have already defined 0 1. Initial state is q0, so there is a input symbol 0 and 1. Initial state q0. Final state set, there is only one final state q1, and this delta is drawn here as a diagram. Okay, now whether this automata is NDFA or DFA, so if I ask the question, you can type in the comment section whether it is DFA or NFA. So what I told you in the previous lecture, on every state of the automata there are 2 states. For every possible input there are 2 possible inputs, 0 and 1. There has to be one and only one transition. So if you want to identify, let's say if I draw the tabular form, so let's say 0 and 1, there are 2 inputs, initial state q0, and from q0, when 0 is coming, you are reaching q1. Okay, when 1 is coming, there is nothing, you don't have any idea about this. That means this automata is NDFA, non-deterministic finite automata. It is finite. Why? Because finite number of states are there. So this is finite state machine, but it is NDFA, non-deterministic. It is. Why non-deterministic? Because when input 1 comes on q0, this machine doesn't have any clue what to do. But for q1 is the final, so this is circled. On q1 it reaches on q1, so for q1 it is fine, but on q0 it is not fine for 1. Okay, so if you want to convert into, you need to draw one more state to convert into the deterministic finite automata. So if you want to make it compulsorily deterministic, then better to draw one more state, and let's say you draw q2, and this q2 you are reaching through 1, so that means I am filling here q2, so that is fine, but I need to write the transaction for q2 also. Now on q2 there has to be one and only one transaction for 0 as well as for 1. So if I put loop here for 0 and 1, it will be on q2. Now this automata is deterministic finite automata. It is not non-deterministic, so n will be deleted. It is DFA now. Although this state is a kind of dead state, I mean you can reach here, but this state will never lead you to the final state because q2 is not the final one. So I hope this is clear. Now let's discuss the language 4. So in this particular language 4, what is the property here is set of symbols are 2 only, set of alphabet is having 0 and 1, and every string, if you focus here, this 1 is common. That means every string is ending with 1. So the end symbol is fixed as 1. Beginning, any combination of 0 1 can occur. Okay, so if this is the situation, let's draw an automata. So you take an initial state, let's say q0. This is the initial one. I am not making this initial as final because in this language there is no epsilon, right? So this is, and then after this the final state you can reach by 1. So if I take one transition from this state, I can take, let's say when 1 is coming, here I am writing 1, then you are reaching to a new state, that is q1, and q1 can be final also because this string set is having 1. So 1 can be a legal string which can be accepted by this automata. So this has to be a final state. Now apart from 1, apart from 1. If 0 comes, so for 0 you can put a loop here. So before 1, n number of 0 can occur. There is not a problem, right? But if you, so such kind of strings can be accepted by this till now. But if after 1, if there is another combination, let's say 0 comes or 1 comes, then what will happen? So because every string is ending with 1, I can put a loop of 1. So if 1 1 1 1 1 1 is coming, that is also, it is fine, it is ending with 1 only. But when 0 comes here, you can move to the previous state and then you can follow the same pattern, right? I hope you can get it. It is not that difficult. So I am putting one transaction. When 0 is coming, I am moving towards the previous state. Now if I ask whether this automata is NFA or DFA, you can easily find out. So Q0 is my initial state. I need to check for every state, for every input, there has to be unique one and only one transaction. So for 0, this is initial state, this is not the final one. Now for this, for 0, Q0 lead you to Q0 only, and for 1 it is leading on Q1. Q1 is the final one, so I circled it. For Q1, when 0 comes, it is leading you towards Q0, and when 1 is coming, it is on Q1. So for every input on every state, there is only unique entry, single entry. That means it is a DFA, deterministic finite automata. Okay, so this will help you to understand how to construct the fundamental automata. We will practice more in further coming lectures. So thank you everybody for connecting. See you in the next class.